So let me explain to you a few things about the electrical grid. One key point is that supply and demand always has to be equal. When there is more demand, you bring supply up, but also when demand comes down, you bring the supply down. When I'm talking about supply, I'm talking about the actual electricity that's being generated at the various sites. This is what the grid managers always do, is they keep supply and demand even. And so they're literally bringing plants up and taking plants down so that it matches demand. It comes as no great surprise that electrical use varies widely across the day, particularly in the summers when you have the summer heating. So you can see this is the difference just to go from 83 degrees to 103 degrees, and you see it's almost double the requirement to operate triple the requirement to operate during the heat of the day than it was during the early morning hours. So this is a part of what you have to think about when you size the electrical generation system. Is you have to be ready to accommodate the worst. Now in Texas, and I'll explain to you why I say now in Texas in a later slide, we have just barely enough capacity for the hottest summer days. So that on the hot afternoons in July and August, literally every generation source in Texas is going full bore, to the point where the grid manager actually has some contracts with some companies that they can start reducing the amount of power that they give them. And that typically happens in the 4 to 6 p.m. time frame when the power demand peaks. But always has to be kept, supply and demand always have to be kept equal. And because of that, they think of different electrical sources different ways. Base load is like, that's the steady eddy. These would be the sources that can generate a lot of power, but they're not very agile in terms of turning them up and down. A good way to think of this is like a nuclear power plant. That thing is just capable of generating electricity all the time at the same rate. Then you have the intermediate, which these are the plants they bring up during the daylight hours, and then the peaking would only be the plants they would have up, say, during the heat of the day. This is how they manage the electrical system. Here's some interesting factoids. There are only 3 major grids in the United States. There are different little zones, but they're kind of all connected together such that there are 3 grids. And literally, it's the East, the West, and down in that yellow, Texas. Very interesting story why Texas is its own grid, but it is. And you see down on the bottom left the abbreviation ERCOT, Electric Reliability Council of Texas. That is the grid manager in Texas. And you see that it doesn't connect as much up into the panhandle. This is why those lines to make wind energy possible were so important, that they built those lines up into the panhandle to connect back in with the rest of Texas. Because Texas is its own grid, it becomes a very interesting study in and of itself. And really, Texas is where the grid in the United States is going in the future. You can see the sources. Coal has been on the decline in Texas for a long time. Nationally, coal is still up quite a bit higher than that, but Texas is heavy into natural gas. No real surprise, since we generate so much of it here, and it's very relatively inexpensive. Nuclear, 8%. We only have 2 nuclear power plants in Texas. I think they're both down in the Houston area. Nationally, that figure is about double that. Wind, we have 17%. That's obviously much higher than for a lot of other states in the United States, because they don't have the wind generating capacity. So what ERCOT's job is all the time be bidding amongst all these sources to make sure that the supply of power meets the demand of power, and managing that system overall so that it's reliable. If you think about it, even though we have power outages, we've never had brownouts where there just wasn't enough power to go around, like has happened in California from time to time recently. So this is a big deal. I've now set the stage. We've talked about solar, we've talked about wind, and we've talked about how they plug into the network. And so we've laid the groundwork to look at the issues as we think about decarbonizing the energy stream and how wind and solar fit into that. So in the next videos, we'll start to take up those issues.